Alright, so today in class we just reviewed our exponent rules, and before we started I just made sure that everybody was aware that whatever's being raised to the power is called the base, and the little number is called the exponent, and it represents the number of times that you multiply the base by itself. So we're going to review the 7 laws or properties of exponents. When you are multiplying two like bases, you're going to add the exponents. So we have an example over here. I've got two bases in this problem. I have x's and I have y's. I'm going to add the exponents of just the x's first. So 5 plus 3 is going to give me 8. Then I'm going to add the exponents of the y's. 1 plus 6 is 7, and we're done. On number 2, this is the rule that says that when you're dividing like bases, you subtract the exponents. Again, we have two bases. I have x to the 5th on top and x to the 3rd on bottom. There are more on top. So I'm going to have x's on top. 5 take away 3 is 2. My y's happen to cancel, so I'm done. On number 3, we were reminded that when we have an exponent on the outside, you're going to distribute this to each base. And if it's a fraction, you're going to remember to do it to the top and the bottom. So on the first example right here, we're going to have 3 times 5, which is going to give me x to the 15. And we're going to have 3 times that imaginary 1, which is going to give me 3. Down here on this bottom problem, I'm going to distribute the 5 to the top and everywhere on the bottom. So we get x to the 10 over x to the 5th, y to the 20th. Then I'm going to go one step further and go do my division rule, because I see that I have x's on top and bottom. I have more x's on top, so 10 take away 5 is going to give me x to the 5 on top. And I have a y to the 20 on the bottom. The next rule that we reviewed is that when you do have another exponent inside, you are going to multiply those two exponents. So b to the x quantity raised to the y is going to be b to the x times y. So it's pretty much like the one we just went over. So this is going to give me x to the 20th and y to the 12th. On number 5, we're reviewing that we can't have negative exponents. To make a negative exponent positive, you simply flip it to the opposite side of the fraction bar and it becomes positive. So b to the negative 1 would flip to the bottom, and a to the negative 2 would flip to the top. You only flip if the exponent's negative. So looking at this example right here, the x to the negative 2 is going to go to the bottom. The x to the 5th is going to stay right where it is. And the y to the negative 3rd is going to go to the top. So only these two negative ones moved. The x to the 5th stayed where it was. You can see that on the bottom, we can continue. So we get y to the 3rd on top. On the bottom, because I'm multiplying, I add the exponents. Number 6 reminds us that anything to the 0 power is 1. So there is no need to simplify anything in here. All of this stuff raised to the 0 power is simply 1. On number 7, we're going to remember that when you have a fraction exponent, the numerator is going to tell you the power, and the denominator is going to tell you the root. So x to the m n power is going to be the nth root of x to the m. So another example here, 2 is the power, 3 is the root. So the cube root of x to the power of 2. So let's do some examples. So on number 1, we have negative 3 raised to the 4th. So what we actually have right here is a negative, and then we have 3 to the 4th. 3 to the 4th means 3 times 3 times 3 times 3, which is 81. Remember that our negative is out here. On number 2, what's being raised to the negative 3 is the x, not the negative 2. So the negative 2 will stay where it is. The x to the negative 3 will move to the bottom and become positive. On number 3, we have y to the negative 9. Again, negative exponents are not okay, so it's understood to be on top right now. I move it to the bottom. I put a 1 on top to hold the place. On number 4, the top is multiplication, so I'm going to add my exponents. So I get x to the 4th over times y to the 8th over On the bottom, I've got powers on the inside and outside, so I'm going to distribute and get x to the 12 and y to the 4th. Now I've got a division problem, so we're going to subtract. I've got more x's on bottom, so we're going to have x to the 8th on the bottom. My y's, I have more on top. I'm going to subtract, and I got y to the 4th on top. Number 5, we've got a negative exponent, x to the negative 8. So I have to move it from the top to the bottom. I already had an x to the 3rd on the bottom, so it stays. I put a 1 on top to hold the spot. On the bottom, we're going to go add our exponents, and I get x to the 11th. Number 6 is a lot like number 3. We're going to fix the negative 8 by moving it to the top. Once I move it to the top, there's nothing on the bottom, so I'm done. On number 7, there are many ways to do this problem. I'm going to choose to distribute my negative 3 to each exponent first, and I get x to the 6th, y to the negative 6th, and I bring down z to the 5th. I have to go fix my negative exponent, so x to the 6th and z to the 5th stay on top. That y to the negative 6th is going to move to the bottom. Number 8. 6 is being raised to the negative 2. So the 6 to the negative 2 goes to the bottom. This negative 1 stays on top. So we have negative 1 over 36. On number 9, I'm going to move my negative 2 first. So I'm going to have a over a squared a to the 3rd. I'm going to add the exponents on the bottom and get a over a to the 5th. I'm going to subtract exponents and get 1 over a to the 4th. On number 10, I'm going to distribute my exponent to the tops and the bottoms, and I get x to the 4th, y to the 8th, over x to the negative 4, y to the negative 8. Now I'm going to take my negative exponents and I'm going to move them to the top. When I move them to the top, I'm going to have nothing left on the bottom. So my final answer is x to the 8th, y to the 16th. On number 11, I have x to the negative 3, so it's going to move to the bottom. The 3 stays on top. Times, if I multiply these two exponents, I get 2 to the negative 4. I have to go fix my negative exponent, so I'm going to rewrite the first part. When I fix it, I get 1 over 2 to the 4th. I'm going to multiply top times top, and I get 3. Bottom times bottom, 2 to the 4th means 2 times 2 times 2 times 2, which is 16. And then I have my x to the 3rd. On number 12, I'm going to fix the negative exponent first. So when I fix the negative exponent, I'm going to take everything on the inside and I'm going to flip it and then raise it to the positive 2/3. We're going to remember that the top number is the power and the bottom number is the root. So I'm going to take the cube root of 27 and then I'm going to square it. I'm going to take the cube root of 8 and then I'm going to square it. So I'm thinking to myself, what number times itself 3 times is 27? 1 times 1 times 1 is 1, not it. 2 times 2 times 2 is 8, not it. 3 times 3 times 3 is 27. So the cube root of 27 is 3. And then I'm going to do the cube root of 8. 1 times 1 times 1, not it. 2 times 2 times 2, that's it. So I have 2. Now I just have to square them both, and I get 9 over 4. 13 is going to work the same way. I've got a negative fraction exponent. So to make it positive, I have to flip the fraction on the inside. Then I'm going to go rewrite this as the square root of 25 over the square root of 16. The square root of 25 is plus or minus 5, and the square root of 16 is plus or minus 4. Number 14, 15, and 16 are all different from the first 13 problems because these 3 problems all have more than one term. And I know they have more than one term because there's a minus sign. So this is 2 terms, there's a minus sign. This is 2 terms, there's a plus sign. This is 2 terms. All the other problems, if you'll notice, there were no plus signs in here. Same thing with 5, 6, and 7. No plus signs. Same thing with 8, 9, and 10. No plus signs. And the same thing with 11, 12, and 13. So these have a lot of the same rules, but some different strategies. So on 14, I can't have a negative exponent, so I'm going to take care of that by moving this y to the negative 1 up to the top. So I'm going to write equals y to the positive 1. Because there's more than one term here, I have to go put these in parentheses. And because I'm putting in parentheses, I'm going to go distribute like we did in Algebra 1. So I'm multiplying, and when you multiply, you add the exponents. So 1y times 2y to the third is going to be 2y to the fourth. Then we do the next term. 1y times negative 4y to the fifth is going to be negative 4y to the sixth. And then you're going to look at your exponents, and you're going to see that I have a y to the fourth and a y to the sixth. So I'm done. All right, number 15 is really different because what a lot of y'all want to do, because we've been doing this over and over, is you want to go distribute these 2 exponents. You cannot do that because there are 2 terms. But what I can do is go on the inside and get rid of my negative exponents, and then once I get rid of those negative exponents, I can take care of the one on the outside. So I'm going to go inside and rewrite x to the negative 1 as 1 over x minus y to the negative 1 as 1 over y, all raised to the negative 1. Now I'm going to go subtract these 2 fractions, and remember that when I'm subtracting fractions, I need a common denominator. Because it's letters, I just multiply them. So my denominator is going to be xy. And because I need an x and a y, this fraction, I have to multiply top and bottom by y. And the second fraction needs an x, so I multiply top and bottom by x. So on the top, y times 1 is y minus x times 1 is x. So we have y minus x over xy, all raised to the negative 1. Now, because I have the negative 1 out here, to make that a positive, I simply take what's inside and flip it. On number 16, again, you're tempted to go distribute that 2 to these imaginary exponents, but we're not going to do that because there's more than one term. Instead, I'm going to go write down what this means. A plus b times a plus b. And then I'm going to remember how to FOIL. So a times a is a squared. A times b is a b. B times a is another ab. And b times b is b squared. Then I'm going to collect my like terms. So a squared plus 2ab plus b squared. Okay, so 17 and 18 are practicing what we just did one more time. So on 17, I'm going to take care of the inside first, just like we did a second ago. So 1 over a squared plus 1 over b squared. So my new denominator, I'm going to multiply these 2 together and get a squared, b squared. And I multiply top and bottom of the first fraction by b squared, and the second fraction by a squared. So I get b squared plus a squared raised to the negative 1. Now I have to take everything inside and flip it to make that negative a positive. So a squared, b squared over b squared plus a squared. All right, the last one we're going to do, number 18. I'm going to move this up to the top like I did earlier because there's more than one term. I'm going to remember to put it in parentheses. I'm going to go distribute. Because we're multiplying, we add our exponents. I get x to the 8th plus x, and you're done. Okay, so I did give you a homework assignment. It's going to be due on Wednesday. Remember, you have a test Thursday. Tomorrow, we're going to be doing a lot of these problems together, but go ahead and start studying your rules because you are going to have a quiz the last 10 minutes of class tomorrow.